I spent 66% of my working hours last quarter fixing AI-generated code, not writing architecture, not mentoring my team, not solving hard business problems. I was copy-pasting from Copilot, reprompting Cursor, and validating outputs that looked absolutely perfect. Clean variable names, proper indentation, even comments, until they hit production and silently corrupted a financial ledger at 2 a.m. on a Friday night. 25 years of experience, and I had become a glorified AI babysitter. Here is the part nobody talks about in the hype cycle. AI-generated code does not fail loudly. It fails quietly in edge cases your test suite never covered, in race conditions that only appear under real load, in business logic that the AI had no way of knowing because it lived in a decade-old requirements document, but he uploaded. The code looked right. It passed linting. It even passed code review, because I was tired and I trusted the tool. That incident cost us 3 days of rollback, all hands postmortem, and a conversation with the CTO I never want to have again. By the end of this lecture, I will show you exactly how to make sure that never happens to you. And more importantly, how to turn that painful pattern into your single biggest career advantage in the AI era. In early 2024, the CEO of Cursor made a statement that sent shockwaves through engineering communities on X, Hacker News, and every Slack channel I belong to. He said, and I am paraphrasing, that AI already writes the majority of code at many companies, and that percentage is only going up. On the surface, that sounds like progress. But sit with that statement for a moment if you are a senior developer. If AI writes the code, what exactly are you doing all day? The uncomfortable answer, for a lot of us, was this. We were reviewing AI output, approving AI output, occasionally fixing AI output. We had gone from being the craftsperson to being the inspector on an assembly line, except the assembly runs at the speed of tokens per second and never gets tired. This is what I call the identity crisis nobody prepared us for. We spent years building expertise in writing good code. We have strong opinions about naming conventions, solid principles, database indexing strategies. And now the question is not whether our code is good. The question is whether we even need to write it anymore. But here is the twist. That framing is completely wrong, and I will prove it to you right now. This identity question exploded into a full public debate on Geek News, Korea's equivalent of Hacker News, when a developer with 5 years of experience posted a thread that hit close to home for thousands of people. The title was something like, I have been using AI tools for 8 months, and I feel like my brain is getting weaker. The replies were brutal in their honesty. Developers at the 3-year mark said they could no longer solve medium difficulty algorithm problems without AI assistance. Developers at the 7-year mark said their system design instincts had gotten rusty because they stopped making architectural decisions from scratch. And here is the timeline that should scare you. In 2020, a developer with 5 years of experience had 5 years of scar tissue, failed deployments, hard debugging sessions, architectural mistakes they personally owned. In 2025, a developer with 5 years of experience might have 5 years of prompt writing history and very little else. The skill gap is not theoretical. It is already showing up in technical interviews, in code review quality, and in the ability to diagnose production incidents without AI assistance. So before we talk about the future, we need to be honest about what is already happening right now. Because the solution I am about to show you depends on you seeing this gap clearly. And that solution? It flips everything you think you know about what a senior developer is supposed to do. So, is the reframe that changed everything for me. And I want you to sit with this before we go any further. Addy Osmani, engineering director at Google, talks about what he calls the 70% problem. AI gets you 70% of the way to a working solution very fast, and then the last 30% is where everything falls apart. That last 30% is not a coding problem. It is a judgment problem. It is a domain knowledge problem. It is a systems thinking problem. And here is the brutal truth. A 3-year developer cannot reliably navigate that last 30%, but you can. If you know what you are looking for, the new senior developer role is not person who writes the best code. It is 4 specific, high-leverage roles that AI cannot replicate. First, the system architect, the person who defines the constraints AI must operate within before a single line is generated. Second, the quality gatekeeper, the person who knows instantly when AI output violates business rules, security invariants, or performance contracts that were never written down. Third, the AI orchestrator, the person who decomposes complex problems into AI-solvable chunks and assembles the outputs correctly. And fourth, the domain expert, the person who carries the institutional knowledge, the regulatory context, the failure history that no training data set contains. These 4 roles are your career moat, and I am going to show you how to build them. Now let me be specific about what you will walk away with from this lecture series, because I hate when instructors promise transformation and deliver theory. Here is the exact transition roadmap we are going to build together. In Chapter 2, we are going to look at precisely where AI breaks down in real production environments, not edge cases in a lab, but the actual failure patterns I have documented covering SI projects, fintech systems, and early-stage startups. You will recognize these immediately. In Chapter 3, we go deep on the architect role. How to write architectural decision records that constrain AI output before it ever runs, and how to use context engineering instead of prompt engineering. In Chapter 4, the Quality Gatekeeper, I will give you a concrete checklist for AI code review that catches the 23 most common silent failure patterns, the ones that pass all automated checks and still destroy production. In Chapter 5, AI orchestration, how to decompose a feature request into a directed acyclic graph of AI tasks and maintain coherence across the outputs. And in Chapter 6, we close with the career positioning framework, how to make your new role visible to your organization, how to price it correctly, and how to make sure you are never again the person 6% of their time cleaning up after a tool. The roadmap is concrete. The skills are transferable, and everything I am about to show you, I learned the hard way, so you do not have to. We are going to look at exactly why AI fails in the places seniors should shine, and the patterns are going to surprise you. Here's a number that should stop you cold. 70%. Addy Osmani, Google Chrome engineering director, the person who literally wrote the book on web performance, published a finding that AI coding tools consistently deliver rough 70% of a correct solution, and they deliver it fast. Suspiciously fast. That speed is exactly what makes this dangerous. The code compiles, the tests pass, the PR looks clean. But that remaining 30%, correctness under edge cases, security posture, regulatory fit, architectural alignment, that 30% is where production systems actually live or die. And here's the brutal irony. The faster AI gets you to 70%, the more invisible that missing 30% becomes. Junior developers celebrate. Senior developers should feel a chill. By the end of this chapter, you'll have a precise map of exactly where that 30% hides, and why finding it is your most defensible skill in 2025. Now let's get off the abstract highway and into the real production environments you actually work in. Because Osmani's 70% number was measured in a Silicon Valley context, greenfield projects, well-documented APIs, English language codebases. The moment you apply that same AI to a Korean SI project, a fintech startup, or a regulated financial institution, the ceiling drops hard. In Korean SI environments, you have ERP integrations with undocumented field mappings, government API specs written in 2009, and business rules that exist only in a retired architect's memory. AI has zero context for any of that. In fast-moving startups, the danger is different. AI matches the velocity culture perfectly, so nobody slows down to question whether the generated auth logic actually meets ISMSP certification requirements. And in financial production, I've personally watched AI generate transaction rollback logic that was textbook correct for MySQL, but silently wrong for the specific Tubero dialect running on the legacy core banking system. The 70% ceiling isn't uniform. It shifts by domain, and the drop is steepest exactly where the stakes are highest. Let me make this concrete with a table you can actually use as a diagnostic tool on your own team. The 70% ceiling doesn't manifest the same way in every system. It has distinct failure signatures, depending on what kind of system you're building. In legacy modernization projects, AI's blind spot is undocumented system coupling. It sees the code in front of it, not 15 years of architectural decisions woven into how that code connects to everything else. In regulated financial systems, the failure mode is compliance logic. AI knows what a JWT token is, but it has no idea your firm's FSSS audit requires transaction logs stored in an immutable append-only format with specific hash chaining. In fast-moving startup environments, the failure shows up as scalability assumptions. AI writes code, works perfectly for 100 users, and silently collapses at 100,000. And across all three, the common thread is this. AI's output looks authoritative in exactly the areas where it has the least actual knowledge. That's not a bug. That's how large language models work. And recognizing that pattern instantly, that's your value. But wait, knowing the pattern is one thing. Seeing it fail in live code is another. That's exactly what we're going into next. I've been cataloging AI failures in production systems for the past 2 years, and patterns emerge. They repeat. Once you see them, you cannot unsee them. Let me give you the first two. Pattern 1, domain knowledge absence. AI generates business logic based on statistical patterns from public code, not from your company's actual business rules. In one Korean insurance project I reviewed, AI generated a premium calculation function that was mathematically correct for a generic insurance model, but wrong for the specific loss ratio formula mandated by the FSS regulatory circular from 2021. It compiled. It unit tested clean. It was wrong in a way that would have caused millions in incorrect payouts. Pattern 2. Edge case blindness. AI optimizes for the happy path because the happy path is what dominates training data. It sees a login function and generates credential validation, but it doesn't consider what happens when the LDAP server is unavailable at 2 a.m. on the last day of the fiscal quarter when payroll runs. These aren't random failures. They're predictable, and predictable means preventable if you know what to look for. Which raises the question, what does the security failure pattern actually look like in code? I'll show you the exact lines. Now let me show you the security failure pattern in actual code, because this one physically hurt me the first time I caught it in a PR review. Here's what Git Copilot generated for a JWT authentication middleware in a Node.js backend. Look at the verify call on line 4. It's syntactically perfect. The library call is correct. But the algorithm field is not explicitly specified, which means if an attacker sends a token signed with the none algorithm, this middleware accepts it as valid. That's CVE 2022 B4 9 class vulnerability, the same family that burned multiple production APIs in 2022. Now look at line 7. The user object from the token payload is passed directly into a MongoDB query without sanitization. That's a NoSQL injection vector hiding in what looks like clean, modern code. AI generated this in 4 seconds. It passed ESLint. It passed the basic just authentication test suite. It would have passed my PR review in the first year of my career. It would not pass it now because I've seen this exact failure pattern before in a real breach postmortem. That pattern recognition, built over years of actual incidents, that is a skill no prompt can replicate. Pattern 4 is the one that haunts me most, legacy context blindness. And I want to walk you through this as a process, because it unfolds in stages and each stage looks completely reasonable until the very end. Here's the scenario. Your team has a 12-year-old Java monolith. You ask AI to refactor the customer service class. It's messy, it has godmode symptoms. The refactoring suggestion AI gives you is genuinely good object-oriented design. The new structure is cleaner, more testable, follows solid principles. Every argument for accepting that PR is technically correct. What AI does not know, what is not written anywhere in the code, is that this specific customer service customer build method is called directly via reflection by a batch processing framework customized in 2016 by a contractor who left the company. The reflection call uses the exact med signature that AI just renamed. The batch runs at 2 a.m. on the 25th of every month for payroll processing. You find this out at 7 a.m. on the 25th. This is not a hypothetical. I watched this happen on a project I was brought in to rescue. The refactored code was correct. The deployment was a disaster. The knowledge that prevented this failure lived only in the head of one senior who had been on that project since 2016 and wasn't consulted before the PR merge. Let me consolidate everything we've covered into a single map, because this is the framework you should carry into every AI-assisted PR review from this point forward. 4 failure patterns, 4 distinct intervention points. Pattern 1, domain knowledge absence. Your intervention is business rule validation before any AI output touches production. Pattern 2, edge case blindness. Your intervention is operational scenario modeling, specifically asking what happens when this fails at the worst possible moment. Pattern 3, security vulnerability. Your intervention is a security-focused code review using OWASP Top 10 as your checklist, not just functional correctness. Pattern 4, legacy context blindness. Your intervention is architectural impact assessment using your system knowledge that exists nowhere in the codebase. Notice what all 4 interventions have in common. They require knowledge that cannot be learned from the code itself. They require experience, context, and judgment accumulated over years. That's not a soft skill. That's the hardest skill in engineering. And in the next section, I'm going to reframe this completely, because the ability to catch these 4 patterns isn't a defensive move. It's your most powerful offensive capability in the AI era. I want to stop here and deliver the core message of this lecture, the reversal that completely reframes everything you've been feeling about AI and your own career value. For the past 2 years, the industry narrative has been, AI does 70% of the work, so you need to do more to justify your salary. That narrative is exactly backwards. The senior developer's irreplaceable value in 2025 is not the ability to write code faster than AI. It is the ability to look at AI-generated code and know, instantly, viscerally, from pattern recognition built over a decade of production incidents, that something is wrong. Even when the code compiles. Even when the tests pass. Even when the junior on your team thinks it looks great. That instant recognition is not intuition. It is expertise. It is the compressed result of thousands of hours of debugging production systems, reading postmortems, surviving AM incidents, and building the mental model of how systems actually behave under real conditions, not ideal ones. Here's the uncomfortable truth for anyone who thinks AI makes senior developers redundant. AI is confidently wrong at the exact boundaries where experience most. And the more confident AI sounds, the more dangerous that confidence becomes without a senior engineer to challenge it. The question is not, can AI replace you? The question is, can you see what AI cannot? Let's formalize this so it's not just a motivational argument, because senior engineers need frameworks, not pep talks. ISO 20510 is the international software quality standard. It defines 8 quality characteristics: functional suitability, performance efficiency, compatibility, usability, reliability, security, maintainability, and portability. Here's what AI tooling directly addresses. Maybe 3 of those 8. Functional suitability in the happy path, and portions of usability and maintainability for greenfield code. The remaining 5 quality dimensions: reliability under failure conditions, security posture, compatibility with your specific stack, performance at your specific load profile, and portability across your deployment constraints. Those require a quality gate that is staffed by a senior engineer who knows the system. This is not a soft position. ISO 25110 is an engineering standard. Quality gate review against that standard is a formal engineering activity. When you position your AI code review not as checking someone's homework, but as executing a formal quality gate against ISO 25110, you are not being defensive about AI. You are describing a required engineering process. That framing matters for your team, for your management, and most importantly, for how you think about your own role. In the next chapter, we're going to operationalize this into the first 2 concrete roles: problem definer and quality gatekeeper. These aren't abstract titles. They come with specific workflows, specific tools, and specific outputs that make your contribution measurable. I have to be honest with you, I spent 6% of my AI coding time last quarter just fixing what the AI got wrong. Not because the AI was broken, because I gave it broken problems. Here is the dirty secret nobody talks about. AI does not fail at coding. It fails at understanding what you actually meant. And that gap? That is entirely a human problem. That is entirely your problem as a senior developer. The problem definer is the role that exists precisely because AI is a brilliant executor with 0 business context. Your 10 years of domain knowledge, the reason a payment retry must never exceed 3 attempts, the reason that audit log cannot be async, that knowledge does not live in any training data. Your job is to translate ambiguous human intent into a precise, bounded problem statement that AI can actually solve without guessing. This is not prompt engineering in the ChatGPT tutorial sense. This is requirements engineering at a new level of precision. And here is what will change how you think about your role. The quality of your AI output is a direct reflection of your problem definition skill, not the AI model you chose. Stay with me because the next scene shows exactly how that translation process works step by step. Let me show you the actual workflow. A product manager walks into your Slack and says, "We need a notification system for order status updates." Full stop. That is the entire brief. Now a junior developer, or honestly, most developers under pressure, will take that sentence, paste it into Copilot or GPT-4, and start generating code within 30 seconds. And they will get code. Lots of it. Beautifully structured, wrong code. Here is the 4-step workflow I use before touching any AI tool. Step 1. Stakeholder intent extraction. I ask, what decision or behavior changes when this feature exists? That forces clarity. Step 2. Constraint mapping. I list what the system cannot do, cannot exceed 100 milliseconds latency, cannot store PI in logs, must be ident. Step 3. Requirements decomposition. I break the vague request into atomic subproblems. Notification system becomes event detection, channel routing, delivery confirmation, retry logic, and opt-out management. 5 separate problems. Step 4. AI problem statement assembly. Only now do I write the AI prompt, and it reads like a mini spec, not a wish. Each step adds a layer of precision that the AI is literally incapable of generating itself. But here is the uncomfortable question: what happens when you skip step 2? The answer will surprise you. Now let me show you the measurable difference. Same business request. 2 completely different inputs to the AI. The vague version: write a notification service for order updates. The senior crafted version specifies the service to publish to topic order events consumed by 3 DAMs channels: email, SMS, push, with per channel retry limits of 3, 2, and 5 respectively, must be idempotent using ordered plus event type as duplication key, must not store customer email and application mail in application logs due GDPR Article 17, and must where the SMS provider is down without blocking email delivery. Same AI model. Radically different output. The vague created a monolithic notification class with no retry logic, hard-coded SMTP credentials in the constructor, and a synchronous blocking call that would time out under load. The senior crafted prompt generated a properly decoupled event-driven architecture with a dead letter Q, a deduplication filter, and channel-specific circuit breakers. I measured this on a real project. The vague prompt required 14 follow-up prompts and 3 hours of refactoring. The precise prompt required 2 follow-ups and shipped in 40 minutes. That is a 4x productivity difference. And it came entirely from the problem definition, not from the AI. This is your leveraged point as a senior developer. But wait, even perfect problem definition is useless if nobody reviews the output. That is exactly what role 2 addresses, and the failure mode there is even more dangerous. Let me tell you about the incident that made me formalize the quality gatekeeper role. A senior engineer on my team, 8 years of experience, one of the best, approved an AI-generated payment module in a 20-minute code review. The code looked clean. It was structured, and it had unit tests. It shipped. 3 weeks later, a race condition in the distributed lock implementation caused duplicate charges for roughly 200 customers during a flash sale. The root cause? The AI had generated a rated Aratus SNNX pattern from a 2019 blog post that predated Redlock. The fix was 4 lines. The damage was 200 refunds, a regularity, and 2 weeks of incident bumps. The code looked right because the AI is very good at making code look right. The quality gatekeeper exists because looks right and is right are different dimensions, and only you, with your system context, can verify the second one. Here is the review checklist I now use for every AI-generated code submission. 4 categories, non-negotiable. Correctness. Does it handle concurrency, edges, and failure modes specific to our system? Security. Hard-coded secrets, injection surfaces, authentication bypass patterns. Performance, N+1 queries, unbounded memory growth, blocking I/O in async contexts. Maintainability. Can the next developer understand and modify this without the AI context? Each item on this checklist maps directly to a known AI failure pattern. The next scene shows how to automate the first line of defense, so your human review focuses on what only humans can catch. Manual review catches what humans notice. Automated gates catch what humans overlook at 2 a.m. during a release. Here's how I wire both together in a CI/CD pipeline, specifically tuned to AI-generated code failure patterns. The pipeline has 5 stages that run on every pull request. Stage 1 is secret detection. I use JIT-leaks with a custom rule set that includes AI-generated placeholder patterns, like your API key. Here, believe it or not, actually shipped to production. Stage 2 is static analysis with semgrep using the AI-generated code rule set. It flags the specific anti-patterns that LLMs produce at high frequency. Insecure deserialization, path traversal via string concatenation, and that redlock pattern I mentioned. Stage 3 is dependency audit. AI will pull in packages that were popular 3 years ago and now have critical CVEs. Stage 4 is complexity gate. McCabe complexity over 15 on AI-generated functions is almost always assigned the AI padded the solution. Stage 5 is contract testing. AI-generated API handlers violate the existing OpenAPI spec in subtle ways that unit tests miss. The key insight here is that these gates are not generic best practices. Each one was added after a specific AI failure incident. Your pipeline should evolve the same way. Every AI-caused bug in production becomes a new automated gate. Here is the uncomfortable reality, though. Even a perfect pipeline cannot catch everything. And the way teams respond to that reality creates the most dangerous anti-pattern of all. Now let me describe a scene I have witnessed on at least 6 different teams in the past 2 years. A senior developer, genuinely experienced, well-intentioned, opens a pull request containing 800 lines of AI-generated code. They read the top of the file, nod approvingly at the class structure, scroll quickly to the bottom, check that the test pass in CI, and hit approve. Total review time, 4 minutes. I call this quality theater. It has all the visual properties of a real code review. There is a pull request. There is an approval. There is a name attached to that approval, but no actual quality judgment occurred. The consequences are not theoretical. In one case I was called in to investigate. A team practicing quality theater shipped an AI-generated caching layer that used object identity instead of value equality for cache key comparison. It worked perfectly in the unit test suite, because the test objects were singletons. In production with deserialized objects, the cache hit rate was 0%. Every request went to the database. The system ran for 6 weeks before anyone noticed, because the degradation was gradual. The most dangerous version of quality theater is not laziness. It is overtrust. Senior developers who have been impressed by AI output for 6 months start to believe the AI has internalized their system's rules. It has not. It never will. Your role as quality gatekeeper is not a formality. It is the last intelligent defense between AI-generated code and your users. Coming up next, how to scale this gatekeeping function when you are orchestrating multiple AI agents simultaneously, which is where Role 3 completely changes the game. Let me get concrete about what skills you actually need to build to own these two roles. I will give you the stack in order of impact, highest leverage at the top. The problem definer skill stack has 4 layers. At the top, requirements, engineering precision, the ability to write acceptance criteria that are unambiguous, testable, and falsifiable. Most developers write requirements like wishful thinking. You need to write them like contracts. If you have never studied formal specification techniques, even lightweight ones like given, when, then with explicit edge cases, this is the single highest return skill to invest in right now. The second layer is domain modeling, the ability to represent the real-world system as entities, relationships, invariants, and aggregate boundaries. This is where your years of domain experience convert directly into better AI inputs. The third layer is structured thinking frameworks, specifically issue trees and MES decomposition from consulting, and event storming from domain-driven design. These are tools for decomposing vague problems systematically, not intuitively. The fourth layer, the foundation, is constraint taxonomy, a catalog of the types of constraints that exist in your domain: regulatory, operational, performance, organizational. When you have this cataloged, you stop forgetting to specify constraints in your AI prompts. Here is the skill gap reality check. Most senior developers are strong at domain modeling from years of practice, but genuinely weak at formal requirements precision and constraint taxonomy. Those two gaps are the most common reasons AI output requires extensive rework. And if you think the quality gatekeeper skill stack is simpler, the next scene has a surprise for you. The quality gatekeeper skill stack is shorter, but harder to fake. There are 3 tiers. The first tier is security review fluency, not being a security specialist, but being able to read AI-generated code and recognize the top 10 vulnerability patterns that LLMs reproduce at high frequency. OWASP top 10, yes, but specifically the subset that appears in AI output. Based on my analysis across 12 projects, the most common are broken access control in AI-generated middleware, cryptographic failures from deprecated library usage, and injection via AI-generated query builders. You need these patterns pattern-matched in your brain, not in a checklist you consult. The second tier is performance profiling instinct, the ability to look at a function and estimate its time and space complexity without running it, and to identify the database query patterns that will collapse under production load. This is a skill developed through debugging production incidents, not through reading textbooks. If you have not spent time with APM tools like Pyroscope, analyzing flame graphs from ROMs, add that to your development plan immediately. The third tier is architectural coherence assessment. Can this AI-generated component actually integrate into the existing system without creating hidden coupling, circular dependencies, or bounded context violations? This is the tier that most distinguishes a 10-year senior from a 3-year developer. To close this chapter, Role 1 and Role 2 are not new titles. They are the formalization of what great senior developers have always done. AI just made them more critical and more visible. In the next chapter, we move to Role 3's AI Orchestrator, where you stop reviewing AI output one piece at a time and start directing multiple AI agents as a coordinated system. That is where the productivity multiplier goes from linear to exponential. I used to think being good at prompting was enough. Write a clever prompt, get code back, ship it. That was my mental model for the first 6 months. Then I watched a junior developer on my team do exactly that. Prompt, copy, paste, repeat. And the codebase turned into a patchwork quilt of AI-generated fragments that nobody, including the AI, could reason about anymore. That's when I realized prompting is not orchestrating. The AI orchestrator role is fundamentally different. It's about designing multi-step AI workflows, decomposing a complex engineering problem into discrete subtasks, assigning each subtask to the right AI tool, and managing the handoffs between them. Think of it like being a conductor. The musicians, your AI tools, are individually talented, but without a conductor shaping the tempo, the dynamics, and the transitions, you get noise, not music. The orchestrator is the senior developer who holds the architectural context across the entire workflow, deciding where AI adds value and where human judgment must intervene. And here's the uncomfortable truth. Most senior developers I know are not doing this yet. They're still playing the role of a very expensive prompt typist. The question is, how do you make the transition? That's exactly what the next scene will show you. Let me walk you through a real orchestration workflow I ran last quarter. We needed to add a rate-limiting feature to our API gateway. A junior developer's instinct, and honestly my old instinct too, was to open cursor and type implement rate limiting for my Express API. You get code back. It looks reasonable. But it's missing your Redis cluster topology, your existing middleware chain, your tenant isolation requirements, and your SLA thresholds. It's code that compiles but doesn't fit. Here's how an orchestrator approaches this instead. Step 1. I use Claude to analyze the existing middleware architecture and generate a structured context document. Not code, just context. Step 2. I feed that const document into Cursor with a scope prompt. Given this middleware chain, generate only the rate limit middleware skeleton with these interfaces. Step 3. I use GitHub Copilot inside the actual codebase to fill in implementation details, because Copilot has file context that Claude doesn't. Step 4. I run the output through a validation prompt in GPT-4. Does this implementation violate any of these 5 architectural constraints? Each step has a defined output format. Each handoff carries the accumulated context from the previous step. The AI is doing the heavy lifting, but I'm the one holding the map. Notice what I'm doing. I'm not context switching into 5 different chat windows randomly. The workflow is deliberate, sequential, and validated. But here's where even experienced orchestrators make a critical mistake. And I'll show you that mistake in the next scene. Here's the mistake. Delegation feels like orchestration, but it's not. When you say to an AI implement this entire feature and handle edge cases, you are delegating. When you say given this specific interface contract and these 3 constraints, implement only this one function, you are orchestrating. The difference sounds subtle. The outcomes are not. Delegation gives the AI full latitude to make architectural decisions it has no business making. It doesn't know your deployment environment. It doesn't know why you chose eventual consistency over strong consistency 3 years ago. It doesn't know that your biggest enterprise client has a non-standard time zone configuration that breaks half of all naive date-time implementations. Orchestration is different in one critical way. You inject domain context at every decision boundary. Not just at the start, at every handoff. Think of it as context injection checkpoints. Before any AI step that involves a design decision, you pause and ask, what does this tool know that would change its output? Then you supply that knowledge explicitly. The human checkpoint is not a review step at the end. It's a series of micro-interventions throughout the workflow. That's what separates an orchestrator from a delegator. And that knowledge you're injecting at those checkpoints, where does it come from? That's role 4, and it's the one that truly cannot be automated. Let's go there now. Let me ask you something uncomfortable. If you took all the code in your company's repository, all the Confluence pages, all the Jira tickets, and fed into an AI model, would it understand your system? Technically, maybe. But would it know why your payment service has a 3-second artificial delay before confirmation? Would it know that your data retention policy has a special carve-out for Korean financial regulators that was negotiated in 2019 and is documented nowhere except in the head of one engineer who has since left? Would it know that the reason you're on PostgreSQL 13 instead of 15 is a specific bug in your ORM that the vendor hasn't patched yet? This is tacit knowledge. It's the accumulated scar tissue of years operating a specific system in a specific business context. And it is completely invisible to AI. This is role 4. The domain expert. It is not about knowing every API or every framework. AI is better at breadth than you will ever be. Domain expertise is about depth that only comes from time spent in a specific problem space. Understanding the failure modes, the business invariants, the regulatory landmines, the performance characteristics under your specific load patterns. Here's the counterintuitive claim. In the AI era, domain expertise becomes more valuable, not less. Because the AI raised the floor for everyone, junior and senior alike. The only differentiation left is knowledge that AI cannot have. And the next scene shows you what to deal with that knowledge. Here's the trap that even great domain experts fall into. They hold all this critical knowledge in their heads, and that means it dies with their tenure. When they leave, or when AI tools ask for context, there's nothing to give. So the domain expert's job in the AI era is not just to have the knowledge, it's to make it explicit, structured, and injectable. The most practical tool I've seen for this is the Architecture Decision Record, or ADR. Not a novel concept, but suddenly it becomes mission critical when your AI tools need context to make good decisions. An ADR captures 4 things: the context, the decision, the consequences, and crucially, the rejected alternatives and why they were rejected. That last part is the gold. AI can propose solutions. It cannot know why you rejected a perfectly reasonable solution 18 months ago because of a vendor SLA negotiation. When you have a library of ADRs, you can inject them directly into your AI orchestration workflow. Here are the last 5 architectural decisions relevant to this feature. Make sure your output is consistent with them. Suddenly, your AI isn't generating generic best practice code. It's generating code that fits your system's decision history. The payoff is compounding. Every ADR you write today is context your future AI workflows can leverage. But there's a deeper strategic question here. Should you be going broader or deeper in your expertise? And the answer might surprise you. There's a career strategy question that comes up every time I give this talk. Someone in the audience always says, but shouldn't I be learning more tools, more frameworks, more AI capabilities? Shouldn't I go broader? And my answer is, that's exactly what AI is for. AI is the best breadth engine ever built. It can learn a new framework in the time it takes you to read the README. What AI cannot do is go deep into your domain, your system, your organization. So in the AI era, the strategic move for a senior developer is deliberate domain deepening, not breading. The generalist who knows a little about everything is being commoditized, because a little about everything is exactly what AI does at superhuman scale. The specialist who knows everything about a specific domain, your payment processing edges, your real-time trading system latency characteristics, your healthcare data compliance landscape. That person becomes exponentially more valuable as AI raises the floor for everyone else. The gap between AI-assisted generalist and domain expert with AI grows every year. Choose your side deliberately. And in the next section, I'm going to give you a concrete roadmap for building both the orchestrator and the domain expert capabilities, because they're not separate tracks. They reinforce each other in ways that will fundamentally change how your team sees you. Let's get concrete. If you walked away from this chapter today and wanted to start building the AI orchestrator skill set, what would you actually do? Here's the stack from foundation to advanced. At the base, you need advanced prompt engineering, not the basics, not write me a function. I mean structured prompting, chain of thought decomposition, constraint specification, output format contracts. This is the grammar of AI orchestration. Next layer up, tool API integration. You need to be able to call AI APIs programmatically, not just through chat UIs. Understand token limits, context window management, cost optimization. Know the difference between what Cursor is good at versus what Claude 3.5 Sonnet is good at versus what a fine-tuned model is good at. Above that, workflow design. This is where your software architecture instincts become your superpower. Designing AI workflows is just distributed systems design with non-deterministic nodes. You already know how to handle that unreliable services, retry logic, output validation, circuit breakers. Apply those patterns to AI pipelines, and at the top of the stack, output validation frameworks. This is the most underrated skill. Most developers validate AI output by reading it. That is not a framework. A framework means defined acceptance criteria, automated consistency checks, regression test cases for known failure modes. Without this, your orchestration pipeline has no quality gate. And remember, this stack doesn't make you a better prompt engineer. It makes you an architect who happens to use AI as infrastructure. That's the reframe that changes everything. But building the orchestrator skills is only half the picture. The domain deepening strategy is where the real compounding happens. For domain deepening, the strategy is simpler but requires a longer time horizon. And that's actually the point. Start by mapping what you know that is genuinely unique to your system. Not generic knowledge. Not things GPT-4 could answer from Stack Overflow. The stuff that only exists because you were in the room when decision was made. Then systematically externalize ADRs for architectural decisions, runbooks for operational knowledge, decision maps for business rule exceptions. Build a personal knowledge graph of your domain. Even a simple Obsidian vault with linked notes is infinitely better than keeping it all in your head. Second, deliberately position as the go-to expert in your team. Every time someone asks a question about your domain, write the answer down in a searchable, referenceable format. Over 6 months, you become the organizational knowledge hub. And that is a position that compounds. Third, make your knowledge AI injectable. Tag your ADRs. Structure your runbooks as prompt-ready context documents. When you can say I can give any AI tool perfect context about our payment domain in 30 seconds, you have achieved something no generalist can replicate. Finally, consider mentorship as a knowledge audit. Explaining your domain to someone forces you to make implicit knowledge explicit, which means you discover the gaps you didn't know you had. Here's what I want you to walk away with from this entire chapter. Roles 3 and 4 are not separate jobs. They are the same senior developer, operating at 2 different time horizons, orchestrating AI workflows today, and deepening domain expertise for the compounding value of tomorrow. The next chapter is where this gets real, because I'm going to show you war stories where AI confidence, at 70% to completion, caused actual production failures. And the developers who caught them in time. Every single one was playing either role 3 or role 4. I have to be honest with you. I was the senior architect who signed off on that deployment. The AI had refactored our payment transaction handler, clean code, beautiful abstractions, all 847 unit tests green. We went live on a Friday. By Saturday morning, we had 23 transactions where money left one account but never arrived in the other. Here is what happened on that timeline. The AI restructured the nested try-catch blocks into a cleaner pipeline, and in doing so, it broke the atomicity guarantee under concurrent load. The tests never caught it because our test suite ran transactions sequentially. Production runs them in parallel. The AI had no idea about our concurrency model, it only saw the code in its context window. I had the context, I knew our load patterns, but I trusted the green tests and shipped anyway. That gap between what AI sees and what seniors know cost us 48 hours of incident response. But wait, that was just the financial system. The security incident that came next was even harder to explain to the board. 6 months later, a different project, a different team, but the same pattern. A fintech client asked us to accelerate their OAuth 2 implementation using AI-generated code. The AI produced something that looked textbook correct. Authorization code flow, PKCE, proper token expiry headers. Their internal QA team ran the standard suite, all clear. Then the external penetration testers came in. Within 4 hours, they found an authentication bypass. The AI had implemented the state parameter validation, but it validated the state after setting the session cookie, not before. A classic talk-to race, time of check to time of use, which is OWASP AO01, broken access control territory. No automated linter flagged it. No static analysis tool caught it. Because the code was individually correct, the vulnerability was in the sequence of operations, not in any single line. Only a senior engineer, who had read the OAuth 2 RFC threat model section, and had personally been burned by a talk-to bug in 2018, would have spotted this. That is institutional memory. That is the gap AI cannot fill. And it gets worse. The third incident involved a legacy system, and this time, the senior who knew the hidden dependencies had already left the company. The third incident is the one that still keeps me up at night, because it was entirely preventable and entirely my fault as the project lead. We had a legacy billing module, 15 years old, undocumented, written by an architect who had retired 3 years prior. The business wanted it modernized. The AI did a remarkable job on the surface. It extracted the core logic, removed dead code, rewrote it in a clean service-oriented structure. The new module passed every test we had written for it. We deployed. Within 2 hours, the customer notification service went silent. Then the revenue recognition pipeline stalled. Then the regulatory reporting job failed to run. 3 separate systems had been silently coupling to internal objects inside that billing module. Not through any documented API, not through any interface contract, just direct object access that someone had added in 2017, without ever updating the architecture docs. The AI had no way to know. Our test suite had no way to know, only the retired architect knew. And we had not called him. The process of breaking these hidden dependencies looked like this, and once you see this pattern, you will never trust a modernization effort without a full dependency audit again. And after those 3 incidents, and honestly, several more I did not have time to cover today, I sat down and mapped the anatomy. And here is what I found. Every single AI product failure I have witnessed shares the exact same 3-node structure. Node 1. AI operates without full context. Not because the AI is bad, the model is doing exactly what it was designed to do. It is reasoning over the code it can see. Node 2. The senior developer has the missing context, but defers to AI confidence. This is the critical failure point. We abdicate our judgment because the code looks clean and the tests are green. Node 3. There is no checkpoint, no mandatory gate, where senior judgment is formally inserted back into the process. The junior trusts the AI. The senior dev trusts the junior. The CI pipeline trusts the tests. And nobody owns the context gap. When I drew this mind map for my team, one of my engineers said, "So the AI is not the problem, we removed ourselves from the circuit." And that is the insight that changes everything about how you position your value. The question you should be asking right now is, how do you know when AI confidence is actually a warning signal? That answer is coming in the next 60 seconds. Here is the counterintuitive truth that I now teach every senior on my team. When AI output looks the most confident, that is precisely when you should apply the most scrutiny. I call this trust calibration. It is a core senior skill, and it is one that AI will never have about itself. Think about it this way. A junior developer writing uncertain code adds comments, asks questions, flags edge cases. An AI generating uncertain output looks exactly the same as an AI generating correct output, fluent, clean, well-structured. The confidence signal is flat. So you cannot use the quality of the output as a proxy for correctness in high-stakes domains. Instead, you need domain-specific verification heuristics. For concurrency, does this code mutate shared state? For security, does the sequence of operations match the threat model, not just the individual calls? For legacy integration, Have I mapped every collar before touching internals? These heuristics are not checkable by AI, they require your contextual knowledge. Your senior instinct is not a soft skill. It is a formal verification system that runs on 15 years of accumulated failure patterns. The question is whether you have externalized that system into a repeatable process, which is exactly what the next scene gives you. So here is the deliverable from everything we just covered in this chapter. I call it the pre-merge senior gate, a checklist that I now make mandatory on every AI-assisted PR that touches production-critical paths. 6 gates. Non-negotiable. First, concurrency safety check. Has any human with knowledge of our threading model reviewed this? Not just the AI and the tests. Second, security sequence audit. Does the order of operations match the documented threat model for this component? Third, cross-system dependency scan. Run your static analysis, A&D manually query your architecture decision records before approving any refactor of a module older than 3 years. Fourth, institutional context interview. If the original author is reachable, a 15-minute call is mandatory before merging any modernization PR. Fifth, can you restore the previous state within 5 minutes if this fails at 3 a.m.? Sixth, blast radius documentation. Write down, before merge, exactly which systems will be affected if this change behaves unexpectedly. These 6 gates are not bureaucracy. They are the externalization of your senior judgment into a repeatable, teachable system. This is how you make your contextual knowledge transferable. And this is you prove your value in an AI-assisted team. Next chapter, we take everything from these war stories and build your personal action plan for this week. Because knowing the pattern is not enough. You need a new job description, and we are going to write it together. I'll be honest with you, for the first 6 months after I adopted AI coding tools, I spent 66% of my time reviewing, patching, and re-explaining AI output. I thought I was productive. I was wrong. The seniors who thrive in this era are not the fastest reviewers. They are the ones who set the frame before AI even writes a single line. So here is the DI to the manifesto. First, own the problem frame. Before you prompt anything, write down what success looks like in business terms. Second, set to the quality bar explicitly. Your team's definition of done must be written before AI generates done. Third, don't just review. You are the conductor of a system that includes AI as one instrument among many. Fourth, invest in domain knowledge every single week, because that is the AI cannot cross. These are not soft skills. These are your new core competencies. If the DO side sounds straightforward, wait until you see what the DONT side is quietly doing to your career right now. Now let's talk about what is actually killing senior developer careers right now, and most people don't even notice it happening. Anti-pattern number 1, the rubber stamp. You get AI output, it looks reasonable, you approve it in 30 seconds. You just outsourced your judgment, the one thing you were hired for. Anti-pattern number 2, context outsourcing. You let AI summarize your own system's history, your own team's past decisions. Now AI knows your code base better than you do, and you've become the junior on your own project. Anti-pattern number 3, skill atrophy. Every time AI it's the hard part and you skip understanding it, you lose one more neuron of deep expertise. In 6 months, you can't catch the subtle bug because you haven't written that kind of code in 6 months. The pattern is insidious. It feels like productivity, it is actually competency erosion. Compare the 2 paths side by side and ask yourself honestly, which column describes your last 2 weeks? The 30-day roadmap coming next is designed specifically to pull you out of the right column before it becomes permanent. Knowing the manifesto is not enough. I've seen plenty of senior developers nod at all of this and then walk back to their desk and do exactly the same thing they did yesterday. So let me give you the concrete 30-day plan I wish someone had handed me. Week 1. Audit your current AI usage. Literally count. How many AI outputs did you approve this week, and for how many did you understand the full reasoning? If the honest answer is less than 50%, that's your baseline. Week 2. Define your team's quality gates in writing. Not in your head, written, shared, versioned. What does a production-ready AI-assisted PR look like on your specific stack? Week 3. Build your orchestration workflow. This means designing the handoff protocol, which tasks go to AI, which must stay with humans, and who owns the integration points. Week 4. Document your domain knowledge. Start with the 3 things only you know about your system, the historical decisions, the implicit constraints, the failure modes you've seen. Get them out of your head and into your team's knowledge base. 4 weeks, 16 working days. This is not a transformation. It is the foundation that makes transformation possible. And if you're a tech lead or CTO, the next scene shows how to scale this across your entire engineering organization. Now, if you're a tech lead or CTO watching this, the individual 30-day plan is just the starting point. Your real job is to make this the default operating model for your entire organization. not just one senior developer's personal workflow. Here's how you institutionalize it. Step 1. Establish an AI governance policy. This is not about restricting AI. It is defining where AI output requires senior human judgment before it touches production. Step 2. Create the role matrix. Formally define what architect, quality gatekeeper, and AI orchestrator mean in your org, and map them to your current job ladder. Step 3. Build the feedback loop. Instrument your CI/CD pipeline to track AI-generated code separately and measure defect rates, review cycle time, and rollback frequency by origin. Step 4. Run monthly war or story reviews, exactly the kind of incident postmortems we covered in the previous chapter, and make them a structural part of your engineering culture. The organizations that do this in 2025 will have a measurable competitive advantage by 2026. The ones that don't will be debugging production at 2 a.m. because a confident AI wrote code nobody truly understood. Let me leave you with this, and I want you to remember it the next time Alex is watching, a junior developer. Get AI to generate in 10 seconds what used to take you an hour. Your value was never in typing code. It was never in memorizing syntax. It was never in being the fastest person in the room to produce a working function. Your value has always been, and remains, in knowing what to build and what not to build. In catching the thing that breaks the system before it reaches production. In holding the institutional memory that prevents the same catastrophic mistake from happening twice. In leading systems that outlast any single tool, any single framework, any AI model. The senior developers who thrive in this era are not the ones who resist AI. They are not the ones who blindly trust it either. They are the ones who understand, at a deep architectural level, exactly what AI cannot see, and who use that understanding to make their entire team smarter, safer, and faster. That is the job. That has always been the job. Now go do it.